Hello everyone. So in the previous video we have discussed about how to find the units and dimensions and the basic parts of units and dimensions. So in this video we are going to discuss about the applications of dimensions. Clear? So basically there are four applications we have. Four applications. So here is the first application about which we'll discuss right now. Finding the dimension of unknown constants. Okay, so all of you see here how to find the dimension of unknown constants. Suppose I will add two parameters like 2 kg and 5 kg. The answer we are going to get is 7 kg. But if I will add 2 kg with 5 kilometer, is it possible to add? No, it is not possible. Clear? Why it is not possible? Here you see I have taken the mass and length. So they belong to two different dimensions, mass and length, so it cannot be added. Similarly, they can also cannot be subtracted. So here you see mass and mass, 2 kg is mass and 5 kg is also mass. I have added two mass to get another mass. So what is the logic behind this? Whether in case of addition or in case of subtraction, there must be they must belong to same dimensions. If they belong to different dimensions, you cannot add them or you cannot subtract them. This is the main logic behind this. So we will apply the same logic to find the dimension of unknown constants. That is the first application which we are going to discuss now, to find the dimension of unknown constant. That means if two physical quantities or two terms or two equations are added or subtracted, then they must have same dimension. Then only their addition or subtraction is possible. Otherwise it is not possible. So here you can see an example, very important example I have written here, that f equals to a root x plus bt square. Here in the question it is given f is force, x is displacement and t is time. So you have to find the dimensions of a and b. Here a and b are unknown to us. We don't know what is the meaning of these constants. So we will find the dimension of these two unknown constants by applying the logic which we have discussed. This logic is what we call is principle of homogeneity. Okay, so let me write down the question. The question says f equals to a root x plus b into t square. Okay, now all of you see carefully here a root x, this quantity a root x is added with b into t square and the result is f. Clear? So you simply apply the same logic here which we have discussed. So here you see if two quantities are added, then they must have same dimension and the result also have the same dimension. So simply we can write here that since a root x is added with bt square, so the dimension of a root x must be equal to the dimension of b into t square, and that must be also equal to the dimension of force. Clear all of you? So the dimension of a root x, here it is equal with bt square and it is also equal with force. Now what we will do is we will put the dimensional formulas of known quantities. So here you see, don't know the dimension of A, so simply write it as A, but we know the dimension of X. It is given here, X is displacement, so in place of X we will put the dimension as L, and root over is as it is there, then B into T square. The dimension of B is unknown, T square, that is time dimension, is capital T square, and the dimension of force we know as mLt minus 2. Clear, all of you? Okay. So after writing this, we'll simply compare A root x with mLt minus 2 to find the dimension of A. So A root L equal to mLt minus 2. So the dimension of A equal to mLt minus 2 upon root over of L. So on solving you will get as m root over of L into T minus 2. So that equals to m L to the power half T to the power minus 2. So this is the dimension of A. Okay. Now we'll find out the dimension of B. So again you have to compare Bt square with mLt minus 2. So I am solving here. Here you can see Bt square is equals to mLt minus 2. So it will be equal to P equal to mLt minus 2 upon T square. So the final answer is, dimension of B is mLt minus 4. Clear? So this is the dimension of B. Okay. So this is the dimension of A and this is the dimension of B. So in this way you can solve, or you can find the dimensions of A and B. So another question you can see here, it is given P is equal to B minus X by AT, where P is power, X is displacement, and the T is time. Okay, so we have to find the dimension of A and B again. So all of you see here, P is power. So the dimension of power we all know is, power is simply work by time. So the dimension will be how much? For work it is m L square T minus 2, by time is T. So the dimension of power is mL square T minus 3. Okay. So we will use this dimension of power. Now all of you see, the equation is given P equals to B minus X upon A into T. Clear? So you can see here that B and X, they are subtracted from each other. Okay. So in this whole equation you can see that these two quantities B and X, they are subtracted from each other. So the dimension of P must be equal to the dimension of X. So now it is very clear that dimension of B will be what? Dimension of B will be L only. Okay. So in this way you can find the dimension of B. Now to find the dimension of A, so simply rearrange the equation as B by AT minus X by AT. Okay. So now you see B by AT, this term is subtracted from X by AT and the result is X. So you can write it as, the dimension of power p is equal to the dimension of x by 80. Clear? So the dimension of a will be how much? It will be p into t upon x. So on solving this, we have just calculated the dimension of power, that is m l square t minus 3 into t upon l. Okay, so on solving this, you will find it as m l to the power 1 t to the power minus 2. So this is the dimension of b. Clear? Sorry, this is the dimension of a. So in this way, you can find the dimensions of unknown constants. Clear, all of you? So what we have to remember is, while adding to physical quantities or subtracting to physical quantities, okay, while adding or subtracting to physical quantities, their dimension must be same. Okay, their dimension must be same. This is what we call the principle of homogeneity. Clear? Okay. So this is the first application. Now we will move on to the next application, that is to check the correctness of an equation. So in this application, you will given a equation just like this, and you have to check whether the equation is correct or not. Okay, so here we will check only by dimensionally the equation is correct or not. Okay, so all of you see here, the equation is written as s is equal to ut plus half at square. Okay, s equals to ut plus half at square. Clear? Now you see here the ut is added with half at square and the result is s. So that means the dimension of ut must be equal to the dimension of half at square, because they are added, and the result is s, that also must be equal with their dimensions. So we will find out individual dimensions. So here s dimension is, s is displacement here, so the dimension of s will be simply l. Now for ut we will find out, u is initial velocity and t is time. The velocity is lt minus 1 into t. So again it is coming as l. Now half at square, half into at square, half is simply a number, a is the acceleration having the dimension of lt minus 2 into t square is the time square. So again the dimension is coming l. So you can see here that l, l and l, these three quantities s and ut and half at square, they all have the same dimension, that is l only. That means the given equation is correct, but we have to write that the given equation is correct dimensionally. Okay, the given equation is correct dimensionally. Whether it is experimentally correct or not, whether it is applicable for numericals or not, we don't know, but we can only write the equation is correct dimensionally. Why we will write like this? Because suppose the equation is given like s equals to ut plus 3 by 4 at square. Then in this case also, if you will prove dimensionally, the equation will come out to be correct. But this equation we all know is not actually correct, or is not numerically correct, is not applicable for numericals. Okay, so while checking the correctness, we only check whether the equation is dimensionally correct or not. Okay, so at the end you must write the given equation is dimensionally correct. Okay, now this is about the second application. Now we'll go for the third application to derive the relation between different physical quantities. Okay, so in this lecture I am only discussing one application, one examples. Another video will come after this lecture, which will cover more numericals, and only will have numericals in that lecture based on the applications of dimension. Okay, so in this video we only try to give you the concepts, how what are the applications of dimension. So I am giving only one or two examples. In the next video we will have more examples. Okay, so in the third application you see to derive the relation between different physical quantities. This is our third application. This is also a very important question. So in this application we will find out the relationships between different physical quantities. Okay, or we are going to derive some equations, or we'll use some we'll find some formulas according to the parameters given in the questions. We will use them and we will derive formulas. Okay, so here you see it is given that centrifugal force depends on mass, velocity and radius. So derive the expression for centrifugal force. Clear all of you? So it is given the centrifugal force, it depends on mass, velocity and radius. Okay, so as per the question given, we will write it as centrifugal force F is proportional to mass, velocity and radius. But all of you see that we don't know how it is proportional or how it is depend. That means whether it is the force is proportional to m, or the force is proportional to m square, or force is inversely proportional to m. Like this, nothing is given in the question. We don't know how it depends. Only this much is given in the question, that the force depends on mass. How it depends, it is not given in the question. So what we will do here is, we'll assume that let force is proportional to m to the power a, v to the power b and r to the power c. Clear? Okay, so now all of you see, you can write it as F equal to k into m to the power a, v to the power b and r to the power c. Clear? Okay, now the next step is, we have to put the dimensional formulas of the known values. The dimensional formula of force we all know is m L T minus 2. Clear? And the dimensional formula for this mass, m is simply m to the power a. For velocity is Lt minus 1 to the power b, and for radius it is L, length only, L to the power c. Clear? Okay, so here this k is a proportionality constant which is dimensionless here. No need to put any dimension for k. Now let this equation be taken as our equation number 1. Now we will solve this given equation and find the value of a, b and c. So it is m L T minus 2 in the LHS part, and in the RHS part it is m to the power a. Now you simply open the brackets, it will be L to the power b plus c. Since their base is same, so you can add the exponents, and the t to the power minus b. Okay, now you simply compare the LHS and RHS. Here you see this M has a power of 1 in LHS, and in RHS the M has a power of A. So you can write here as A equals to 1. Okay, A equal to 1. Now the power of L in LHS is 1 and power of L in RHS is B plus C. So again comparing, we can write B plus C equals to 1. Now we'll compare the power of T, that is minus B equal to minus 2. So B equals to 2. So putting the value of B over here, 1, C equals to minus 1. Clear? So this is the value of A, B and C. So in this way we have found the values of A, B and C. Now we will use these values in the given equation number 1. In this equation we will put this value and we will find the final formula for the force. So on putting the value, you can see that F equals to K into M to the power A. So A is 1 and V to the power B. B is V, the power of V will be 2, and R to the power C, that is minus 1. So the final formula for force, centrifugal force, is K equals to F equals to K into mv square by R. Clear? So in this way you can find the dimensions, use the dimensions and find the formulas, derive the relationships between different physical quantities. Here we have found the relationship between centrifugal force, mass, velocity and radius. So we can here say that centrifugal force is directly proportional to mass and it is proportional to square of velocity and inversely proportional to radius. Clear? Okay. Now we'll move on to the last application. So last application is to convert between different system of units. So between different system of units we need to know how to convert. Okay. So let us take a simple example. Suppose if I will say 1 meter equal to dash centimeter. So you can clearly say it is 100 centimeter. Similarly 1 kilogram, 1 kg equal to dash gram. So you can clearly say it is 1000 gram. But if I will say 1 joule equal to dash arc, okay, then what will be the answer? Similarly 1 newton equal to dash dyne, okay, so what will be the answer? So we have to derive these values, we have to find. Here you see these are the basic quantities, that's why we can directly convert them. We know the conversions, so we can directly write down their conversions. But for derived quantities we need to convert SI quantities into CGS terms or CGS into SI terms. Okay, so let us solve for the first example, that is 1 joule equal to how much arc or how many arc. Okay, so before solving that, let us take a simple example. Suppose I have taken a rod over here. This is a rod whose length we have to measure. Someone measures the length of the rod is 2 meter. Okay. Similarly, another person, let he or she measures it to be 200 centimeter. Clear? So both the readings are correct. 2 meter is also correct. 200 centimeter is also correct. That means here the length is a quantity, physical quantity Q. It can be expressed with a numeric value with a unit. So as I have written 2 meter, so 2 is the numeric value and meter is the unit. Otherwise it can also be expressed with another numeric value and with another unit, just like 200 is another numeric value and centimeter is another unit. Clear? So one quantity can be expressed in many ways. So one numeric value with one unit. If you change the numeric value, then the unit also must be changing. So one unit again, it can be expressed in dimensional form as m to the power a, l to the power b and t to the power c. Similarly, the unit 1 can be expressed as m1 to the power a, l1 to the power b and t1 to the power c. And unit 2 can be expressed as m2 to the power a, l2 to the power b and t2 to the power c. Okay. So now all of you see, we are here trying to convert between different system of units. Okay. So this is one way of writing n1 u1 equal to n2 u2. One quantity can be expressed in both the manners. So both of them are equal only, their value or their magnitude is same only. So to find another unit, let it be u2, what we have to do is we simply do n1 u1 upon u2. Now you simply put the values of u1 and u2 in this given equation. So n2 will be n1 into, putting the values, we can write m1 by m2 whole to the power a into l1 by l2 whole to the power b and t1 by t2, I am writing here t1 by t2 whole to the power c. Clear? So this is the formula to convert one unit into another unit. Again I am writing n2 equal to n1 into m1 by m2 whole to the power a, l1 by l2 whole to the power b and t1 by t2 whole to the power c. Clear? So this is the formula. We'll use this formula to convert one system of unit into another system of unit. Okay, so let us take an example. So the example is we have to convert 1 joule into dash arg. Okay, so here you can see that this is n1 is 1 and the unit 1 will make 2 column here. One is for the SI units and the other one is for CGS units. Clear? Okay, so n1 is given, that is 1, but in CGS you have to find the value of n2. Here it is the n2, we have to find the value of n2 by using this formula. Okay, now in SI we know the value of m1 is 1 kg, we know the value of L1 is 1 meter and we know the value of T1 is 1 second. Similarly, in case of CGS, we know the value of M1 is 1 gram, L1 is 1 cm and T1 is 1 second. Okay, now we will use this given formula to find the value of N2. This formula we are going to use now. Okay, now I'll write the formula. So n2 equals to n1. In place of n1 I am substituting 1 into m1 by m2. So m1 is 1 kg by m2 is 1 gram to the power a. L1 by L2, that is 1 meter by 1 centimeter to the power b, and T1 by T2, that is 1 second by 1 second to the power c. Okay, now what is the value of a, b and c? So you see here the joule or org, these all terms, these all units, they belong to energy, and we know the dimensional formula of energy as m L square t to the power minus 2. So the value of a will be 1, okay, and value of b will be 2, value of c will be minus 2. Clear? So these are the values of a, b and c. The quantity you have to determine. Suppose in case of Newton and dyne, in place of energy you will write here as force, and for them a, b, c will be different. Now we'll put the values of a, b and c. So n2 equal to 1 into 1 kg, we know it as 1000 gram upon 1 gram to the power a. You know the value of a as 1. Now 1 meter is 100 cm by 1 cm, and the power of b is, the value of b is 2, and 1 second by 1 second to the power c is minus 2. So now you have to solve. So on solving this, you will find it as 10 to the power 7. So in this way you can find the value of n2. At the end we can write that 1 joule equal to 10 to the power 7 arc. Okay, 1 joule equal to 10 to the power 7 arc. Clear all of you? So now all of you write down 1 Newton equal to dash dyne. Okay, come on, quickly solve and tell me in the comment what will be the answer. 1 Newton equal to dash dyne. Okay, so this is for the today's lecture. So we have discussed in this lecture how to convert between different system of units, and also we have discussed how to find the dimension of unknown constants, how to check the correctness of a equation, and how to derive the formulas or derive relationship between different physical quantities. Okay, let us have a quick review. This is our fourth application where we have discussed how to convert between different system of units, and this is our third application where we have discussed how to derive relation between different physical quantities, and this is our second application where we have know how to check the correctness of a equation, whether the given equation is dimensionally correct or not, and the next one will be to find the dimension of unknown constants, that is the principle of homogeneity, by using the principle of homogeneity. So in this way we have discussed all the four applications. So in the next video I will upload more and more questions based on these four applications. These are some of the important examples so I have discussed in this video. So in the next video we'll upload some important numericals. Thank you everyone.